Enhanced Interior Gateway Routing Protocol. As I said in the previous class, it is not a proprietary protocol now. It is available for anyone to use. Though it is designed by Cisco, it is no more a proprietary protocol. Enhanced Interior Gateway Routing Protocol. Do you know the metric of EIGRP? Did I say the metric of EIGRP?
I can't recall, sir.
Okay. Metric is bandwidth plus delay.
Delay. Okay.
Yeah. It's a composite value. And the algorithm used to find the best path, a loop-free path, is diffusing update algorithm. Did I say about this?
Yes, sir.
Diffusing update algorithm. Next, the administrative distance. Administrative distance is 90.
90.
Do you remember the administrative distance of RIP?
I think it's 110.
120. 110 is for OSPF.
OSPF, sorry.
That's our next protocol. Okay, this is 90. Now, EIGRP is a classless routing protocol. What does that mean? This can support variable length subnet mask network. You know what is VLSM, right?
Yeah.
We have different prefix length. Because it's a classless protocol, it can very well distribute the routes of variable length subnet mask network. Now, this is the only protocol that can be configured to support unequal cost load balancing. Unequal cost load balancing. See, every protocol supports equal cost load balancing. Every protocol supports equal cost load balancing. This is the only protocol that can be tuned to support unequal cost load balancing. What does that mean? To go from point A to point B, you may have multiple paths. Going via one path over the other path depends on the metric. Let's say, to go this way, to reach Y from X, cost is 10. To go this way, the cost is 15. What do you call this as? Unequal cost path. Unequal cost path. See, equal cost path load balancing is supported on every IGP protocols. Let's say I have 10 here also. Then load balancing is by default supported. Even in EIGRP, it is by default supported. But this one is not supported in any other protocol. EIGRP alone can be tuned. Again, it need to be tuned. It need to be configured. By default, it is not enabled, but can be enabled. Can be enabled so that this traffic engineering. Actually, you can call this as a traffic engineering, so that none of the path will be idle. Because this has got less metric, more traffic will be sent in this and few traffic will be sent in this. For example, 700 traffic out of 1000 and 300 traffic out of 1000 is sent here. According to the capacity, the load sharing will happen, but only if you enable. So this is very important point. If someone is talking to you about EIGRP, you must definitely mention this to prove that you know EIGRP. You should say that the only protocol that can be tuned to support unequal cost load balancing is EIGRP. EIGRP supports unequal cost load balancing. Every other protocol supports only equal cost load balancing. Now, how many paths? Up to 4 paths by default. You can increase it if you want. Similarly, unequal cost load balancing, how many paths? Up to 4. If you want to increase, you can increase in EIGRP. Is this point clear for you?
Yes, sir.
All right. Now, what is next is EIGRP works in a group. EIGRP needs a group ID. We call that as autonomous system number. For all these routers, you should put the same number as an autonomous system number for EIGRP to form a group. Only between the group member, it will form neighbor. Only with the neighbor, it will share the routes. So, forming a group is by using group identification number called autonomous system number. Right? With this, we will get into the lab. We will use one of the lab which we already used for RIP. Running RIP. As a result, if you see, I'm able to ping from here to that remote router 1.1.1.3. See, I'm able to ping, which means there is a route. Let's go check the route. Go to router A and check the route. Show IP route. I can see the routes given by 120 administrative distance protocol, which is RIP. R means RIP here. And it says it's 2 hop away. Whereas 1112 is 1 hop away. So the routes are already there, but not through EIGRP. RIP. Now, if I enable EIGRP, what will happen? EIGRP will preempt RIP. EIGRP will preempt RIP. What does that mean? EIGRP will overcome RIP, override RIP. Why? EIGRP's administrative distance is lesser, 90. So, smaller the administrative distance, more weightage, preference. Let's enable EIGRP on router A now. Same like RIP, only there is no much difference. You see, on router A, we say router EIGRP and the autonomous system number. This can be any number between 1 to 65535. Any number between 65535. Now, I'm going to give number 11. This number has to match with the neighbor. If not, they don't form neighbor. You see, to form neighbor, they send the hello packets. In the hello packets, this autonomous system number is also sent. So the receiving router will check for the autonomous system number. If matches with the local autonomous system number, only then it will form neighbor. So what do you know about autonomous system? It's a number which is globally significant. Global, not local. Next is the networks. The networks that I have are 30 and 10. Done. Finished. EIGRP is enabled. Put no auto summary because by default it will summarize. Anyway, we don't have any classless network. But it is good to say no auto summary so that even if you have classless network, you won't have a problem. See, here I have classless loopback 1112, 1113 on other routers. Okay, so router A is already running EIGRP. How do you verify? Type this command and see show IP EIGRP interfaces. It shows very clearly that there are only two interfaces. EIGRP autonomous system number is 11. In that you have two interfaces running EIGRP. So far no neighbor has been discovered via those wires. That's why it is 00. Now let us move on to router B. Router B has got two networks. What are they? 10 and 20. And also we have 1112. So what I'm going to do, I'm going to say router EIGRP same number 11, network 20, and then 10, and then 1112. See, as soon as I hit enter, it will form neighbor. You see, the neighbor has been discovered. Dual algorithm, dual neighbor change for EIGRP 11 autonomous system number. This is the IP address of router 1. It has formed a neighbor. Neighbor adjacency is up. Now, we have also a loopback, no? So, I can also say like this, 1.1.1.2 and then 0000. This means wildcard mask. This means that all these four numbers, if it matches, then advertise. Whenever you want to match all four octet, only then you want to run EIGRP, then you have to use this wildcard mask. Wildcard masks helps to match beyond the class full. See, here we did not mention any wildcard mask, which means it is class full /8 because it is 10. If it is 172, it is /16. But in this class A /8, I want to match up to 32 bit. So the best option is use wildcard mask. Do you understand, Diva, this one? Wildcard mask?
No, sir. Can you explain again?
I repeat again. When you don't mention wildcard mask, it will match only this 8-bit. Why? Because it is class A. Isn't it? 1 to 126 is what? Class A. Yes or no? IP address ranging between 1 to 126 is class A. So it will match only the first octet on the interface IP and then run EIGRP on that interface. But when I mention like this, it means go and check the interface IP. If it is only all four numbers are same, 1.1.1.2, you run EIGRP. You understand? It won't run EIGRP if you have 1.1.1.3. Why? Because I said match exact. This 0 means what? Match exact. First octet number should match second octet, number should match third octet. All four octets should match on that interface. Which interface? On any of the interface. Show IP interface brief. So this interface matches all four number. Only now it will run EIGRP. Whereas in this case, only when 10 matches, it will start running EIGRP on this interface. 20 matches, it's not trying to match all 4 numbers. It is only trying to match only first number when you don't mention the wildcard mask. But when you mention the wildcard mask, you mean to say all 4 numbers should match. If I have 4-0. If I have 3-0, then all 3 numbers should match. Do you understand now?
Understand now? Yeah.
Okay. Now let us move on to the next router. Router EIGRP11 network. Here the networks are 20 and 1. 1.1.1.3 network 20. So as soon as I say this, the neighbor will come up. See, the neighbor has come up. Now let us check the neighbor. Show IP EIGRP neighbor. You can see the neighbor. This is the IP address of B router. And let's check the routing table. Show IP route. You see, you got the route now, not R, but this time it is D. D means what? Dual algorithm. EIGRP uses what algorithm? Dual algorithm. Show IP show IP route here on router A. Do you see now D instead of R?
Yes, sir.
And also, you see the AD value. Previously it was 120, now it is 90. Now I'll be able to ping from the PC like before. You see? It's pinging with the help of EIGRP route. Alright, so do this exercise and come. We will do one more recap on EIGRP in our next class. Then we will get into OSPF, Open Shortest Path first.